At the very heart of the Milky Way's brilliance, where hundreds of billions of stars silently circle a hidden center, there exists a patch of darkness, like a blind spot in the eye of the universe. A region where light hesitates, where telescopes once looked away, and within that silence, something may be hiding, breathing in rhythm with our galaxy. This video does not promise final answers. It promises a journey to lift the veil of cosmic dust and touch what we have lived beside, yet never truly understood. What do you think lies behind that darkness? Leave your thoughts in the comments, because every idea is a guiding star. And before we go any further, let us begin with the blind spot we are living with. Have you ever tried to understand a cathedral by standing inside it, pressed against one of its pillars, staring up into shadows where the ceiling disappears? That is our situation in the Milky Way. We live inside the very object we are trying to see. And from this interior vantage point, our galaxy does not reveal itself as a neat spiral on a poster. It reveals itself as a lived sky, a river of stars, a luminous haze, and, in one stubborn direction, a silence that feels almost intentional. From Earth, we cannot observe the whole Milky Way in the way we photograph other galaxies, because we are embedded in its disk, like a swimmer trying to sketch the shape of the ocean while waves keep breaking over their head. When we look outward, we see along a crowded plain packed with stars, gas, and dust. That dust is not a metaphor. It is real matter. Grains of carbon and silicates and frozen compounds scattered through space like soot in a beam of sunlight. It does what dust always does. It absorbs, it scatters, it hides. Visible light, the kind your eyes evolved to cherish, struggles through it, loses its way, fades, reddens, and in some directions it simply cannot reach us at all. So the massive blind spot is not a hole in the galaxy. It is a veil, a thick curtain drawn across part of our view by the very material that also makes future worlds, future oceans, future life. It is strangely poetic, really. The ingredients of creation are also the instruments of concealment. And once you understand that, the question changes from, why is there a blind spot, to what is the blind spot made of, and what might it be hiding? Here is the simplest way to picture it. Imagine driving on a cold night, and your windshield fogs from the inside. The city is still there, the streetlights are still burning, but your view becomes a bright smear, a glowing uncertainty. You do not conclude the world ended outside your car. You conclude your window is interfering with your ability to see. Our window is the galactic plane, dense with dust lanes and clouds, and from our seat inside the disk we are forced to look through that fog when we try to map what lies beyond. A second image makes it even clearer. Picture standing in a vast forest, trying to describe the shape of the entire forest by looking sideways through trunks, branches, and mist. In some directions the trees thin, and you can see far. In other directions, the forest becomes a wall. You might sense movement beyond it. You might hear the wind, but you cannot easily count what is there. That is what happens when we aim our telescopes through the crowded, dusty midline of our own galaxy. And yet, science is patient. Science is the art of changing the question until nature is able to answer. When visible light is blocked, we do not surrender. We shift the way we listen. Infrared light can slip through dust more effectively than visible light, like a deeper note traveling through a closed door. Radio waves can pass through regions that appear utterly black to our eyes. X-rays and gamma rays can reveal violent events that carve signatures into the dark. In other words, the blind spot is only blind to one kind of vision. It is not blind to reality. This is where the mystery becomes both scientific and deeply human. Because the moment we admit that our sight has limits, we must also admit something else. Our mental picture of the universe is always partial, always shaped by where we stand and what our instruments can detect. Carl Sagan once offered a line that feels almost written for moments like this. Somewhere, something incredible is waiting to be known. Not somewhere far away only, sometimes somewhere hidden in plain sight, behind the luminous clutter of our own home. So what creates the blind spot in practical terms? Dust is the headline, but it is not alone. The Milky Way's disk is crowded with stars, and their combined light can confuse measurements, overwhelm faint signals, and turn delicate patterns into noise. Gas clouds glow in certain wavelengths and go dark in others. The center of the galaxy adds its own complexity, a region of intense activity, tangled magnetic fields, energetic particles, and layered structures stacked along our line of sight. When you look toward the densest parts of the plane, you are not looking at one clean distance. You are looking through layers, like pages pressed together, and the ink bleeds through from every side. Now let the deeper question arrive, quietly, the way it always does when you stare long enough into darkness. If our view is blocked, could something important be hidden right there, just beyond the curtain? The honest scientific answer is that important depends on what you mean. It might not be a single dramatic object waiting to leap into view. More often, what is hidden is structure. Census lists of galaxies behind the Milky Way, clusters and filaments that help explain why local galaxies drift the way they do. Regions of mass that tug on cosmic neighbors through gravity, even when their light is muffled. Not a monster in the shadows, necessarily, but a missing piece of the map, and missing pieces can distort the entire story. Gravity, after all, is the universe's confession. Light can be blocked, but mass leaves fingerprints in motion. If many galaxies appear to flow in a certain direction, if their velocities have a pattern that seems too coherent to be random, then something is shaping that motion. This is how astronomers suspect large-scale structures behind the blind spot, not by seeing them first, but by feeling their pull through the behavior of everything around them. It is a beautiful inversion. When sight fails, relationship remains. When the eye is uncertain, the dance of matter still tells the truth. John Archibald Wheeler, one of the architects of modern physics, offered a statement that often returns in conversations about observation and reality. We are not only observers, we are participators. In a practical sense, it reminds us that our cosmic story is not written from the outside. It is written from within. Our location inside the Milky Way is not a footnote, it is a defining condition. We are participants in a galaxy that both reveals and conceals itself depending on how we choose to look. And the phrase, "something is inside it," can be understood in a way that is both less sensational and more profound. Inside that blind spot there are certainly stars, gas clouds, star-forming regions, and remnants of exploded suns, and likely distant galaxies beyond our disk as well. Inside it there are motions that can be measured and mapped, even when images are incomplete. Inside it there may be concentrations of galaxies and dark matter that shape the local cosmic flow. Inside it there are signals we are only now learning to interpret, as surveys expand across wavelengths, and as instruments become more sensitive, more patient, more honest about uncertainty. The value here is not fear or shock. The value is humility paired with method. We learn that the sky is not a flat painting. It is a layered reality with hidden depth. We learn that ignorance is not a failure. It is a boundary marker, a sign that says, beyond this point, change the tool, change the approach, change the question, and we learn something quietly comforting. Even in the presence of a blind spot, the universe is still knowable, not all at once, not easily, but piece by piece, like dawn arriving through fog. So when you hear about a massive blind spot, do not imagine a supernatural void. Imagine a natural veil. Imagine a map with a region smudged, not because the territory is empty, but because the ink we used was the wrong kind. Now we are changing the ink. We are learning to draw in infrared, in radio, in motion, in gravitational influence. And with each new method, the blind spot shrinks. Not because the universe changes, but because our relationship with it deepens. If you had to guess, what do you believe is the most important thing hidden behind that curtain of dust? Not a single object, but the most important kind of truth? Is it a missing neighborhood of galaxies that completes the local map? Is it evidence that our cosmic perspective has always been partial? Or is it a reminder that mystery is not a defect in reality, but part of how reality invites us to grow? Tell me your thought in the comments, not just a quick word, but your honest intuition, because this question lives exactly in the hook we started with. We are searching for what we cannot easily see, and in that search, we discover what kind of thinkers we are. And now, with that feeling in mind, let us step forward together into the first scene of the journey, the blind spot we are living with, the direction on the sky where the Milky Way seems to close its eyes, and where our tools, our patience, and our wonder must learn to see in a new way. What if the darkest patch in our sky is not empty at all? What if it is simply a place where light loses its confidence and our eyes lose their authority? When most people hear the phrase interstellar dust, they imagine something like the dust on a bookshelf, drifting harmlessly through a beam of sunlight. But the truth is both subtler and far more powerful. Interstellar dust is a thin, widespread population of microscopic grains floating between the stars. They are not soft like household dust, but more like tiny fragments of rock, carbon, and ice, forged in the outflows of dying stars and the cold chemistry of space. Each grain is often smaller than a bacterium, yet together, across thousands of light years, they become a veil, not a wall you can touch, but a curtain that changes what the universe allows you to see. Here is the first mystery that pulls people in. How can something so sparse, spread through a near vacuum, block anything at all? The answer is not found in thickness, but in distance. Even a faint fog becomes opaque if you try to look through enough of it. And when you look toward the crowded plane of our galaxy, you are not looking through a few miles of material. You are looking through rivers of dust that stretch for thousands of light years. It is like staring through a forest so vast that the spaces between the trees stop mattering. Eventually, the path becomes shadow. Carl Sagan once reminded us, "We are made of star stuff." That is not just poetic, it is literal. The same stellar processes that built calcium in your bones and iron in your blood also built the silicates and carbon grains drifting between the stars. So when dust blocks our view, it is not an alien obstacle. It is our own cosmic ancestry, floating in front of the story like a soft hand over a candle flame. Now imagine this as a simple human scene. You are driving at night through heavy fog. Your headlights are on, bright and confident, but the world ahead does not become clearer. It becomes whiter, closer, and strangely smaller. The beam scatters, bounces, diffuses. Instead of revealing the road, it turns the air itself into a glowing screen. Interstellar dust does something similar to starlight. It scatters and absorbs. It takes sharp points of distant light and smears them into uncertainty. Not because the stars are gone, but because the path between you and them has become busy with tiny obstacles that are perfectly sized to interfere with visible light. That is the key that unlocks the second question. Why does visible light fail? Because visible wavelengths are small enough to be scattered efficiently by dust grains. The physics is simple in principle, almost tender in its logic. When the wavelength of light is similar to the size of the particles it encounters, scattering becomes strong. Blue light scatters more than red, which is why sunsets burn orange and why distant objects in dusty regions look reddened. In astronomy, we even have a name for this gentle theft of blue light. Extinction, a dimming and reddening that increases the farther you look through the dusty lanes of the Milky Way. So the blind spot is not a supernatural gap. It is a place where visible light is bullied into silence by countless grains, each one tiny, each one ordinary, and together unstoppable. If you want another everyday image, picture a smoky room and a flashlight. In clear air, the beam is nearly invisible, and you mostly see what it illuminates on the far wall. In smoke, the beam becomes a bright, floating tunnel, and the far wall fades away. Nothing has changed about the flashlight. What changed is the space between you and the wall. The medium became visible, and the destination became hidden. In the galactic plane, dust makes the medium visible in its effects, and it hides whatever lies beyond. But here is where the story becomes even more fascinating, because dust is not merely a thief. It is also an artist. When dust absorbs energetic light, it warms, sometimes only to a few tens of degrees above absolute zero. Yet that is enough for it to glow softly in infrared. So the same regions that look like blank darkness in visible light can become luminous in infrared surveys. It is as if the galaxy is speaking in a deeper voice, one our eyes cannot hear, but our instruments can translate. The blind spot is often not blind to the universe. It is blind only to us, in the narrow band of light we evolved to see. That brings us to the third question, the one that feels philosophical even when answered scientifically. Is the darkness real? Or is it simply the edge of our senses? The most honest answer is that it is both, depending on what you mean by real. The dust really is there. It really does block visible light. The darkness you see is a genuine reduction of visible photons reaching your eyes. But the emptiness you might feel when you look into that dark region is not real, because behind the dust, the galaxy continues. Stars continue. Nebulae continue. And far beyond our own galaxy, other galaxies may be stacked along that line of sight, waiting like distant cities behind mountain fog. Edwin Hubble once wrote, "Equipped with his 5 senses, man explores the universe around him and calls the adventure science." It is a beautiful line, and also a quiet warning. Our senses are a starting point, not a verdict. The universe does not limit itself to what our eyes can register. It offers the full spectrum, and we, with our fragile biology, have to build new eyes to meet it. So when people say, there is a massive blind spot in our galaxy, it helps to reframe it. It is not a hole in reality. It is a reminder that reality is larger than our preferred window into it. Visible light is just one language. Dust is like a translator that refuses to speak in that language, forcing us to learn another. Infrared, radio, X-rays. Each one reveals a different truth. Not because the universe changes, but because our questions finally arrive dressed in the right wavelength. And if you listen closely, there is something almost meditative about that. The cosmos does not shout. It does not rush. It allows misunderstanding for centuries, then opens a small door when we become patient enough to build the key. A dark lane across the Milky Way can look like a wound, but it can also be seen as a teacher. It teaches humility. It teaches method. It teaches that not seeing is not the same as nothing being there. So the next time you hear someone call that region empty, remember the fog and the flashlight. Remember the smoky room and the lost wall. Remember that the darkness is not a monster. It is a mask. And behind a mask, there is always a face. In the next part, we will lean closer to that face. We will step into the blind spot we are living with and learn how scientists began to peel back the veil, not with guesses, but with new kinds of light. What if the greatest mystery in our neighborhood is not a distant galaxy or a black hole millions of light years away, but a quiet patch of sky we have stared through for decades without truly seeing? What if the Milky Way itself is hiding something in plain sight? For a long time, astronomers treated this region the way sailors once treated a blank space on a map. Not because it was unimportant, but because it was dangerous to trust. Near the flat band of our galaxy, the sky becomes crowded beyond reason. Stars stack on stars, like glitter thrown into a beam of light. And between them lies dust, cold grains of carbon and silicates, so fine and so patient that it can swallow starlight the way fog swallows a lighthouse. In visible light, that dust does not merely dim the universe. It rewrites it. Early sky surveys were built on optical light, the same light your eyes use to read these words. And optical light is easily bruised. It scatters, It fades, it surrenders. So when astronomers pointed their telescopes toward the plane of the Milky Way, they did not see a clean window into deep space. They saw a storm of foreground stars, a blizzard of confusion, and behind it, the faintest suggestion of shapes that could not be trusted. It was like trying to count houses on the far side of a city while standing in front of a stadium's floodlights. You might glimpse outlines, but you cannot tell what is real and what is glare. That is the first reason this region was ignored, not out of laziness, but out of caution. Science does not only ask what is there, it asks what can be measured without fooling ourselves. And for decades, the Milky Way's midplane was a place where measurements lied easily. The stars of our own galaxy pretended to be distant galaxies. The dust pretended the distant universe did not exist. Catalogues looked clean, but they were clean in the way a room looks clean after you shove everything into a closet and close the door. The second reason is more human and more subtle. Astronomy is a discipline of patterns. We learn the sky by its regularities, clusters, filaments, walls of galaxies, the architecture of the cosmos. But the zone of avoidance did not offer patterns. It offered gaps. And gaps, in the early days, were treated as missing data rather than as a mystery worth its own attention. Not because the gap was small, but because it felt like a wound in the map, too messy to touch, too uncertain to publish, too likely to embarrass the careful scientist. And yet, the universe has never promised to cooperate with our comfort. As Neil deGrasse Tyson put it, "The universe is under no obligation to make sense to you." That line lands differently when you realize the universe can hide entire structures behind a veil made of dust and still keep tugging on everything around it with gravity, as if to say, "You may not see me, but you will feel me." So, how many galaxies are hidden behind this blind strip of sky? The honest answer is that we do not know with perfect completeness. And that is precisely the point. But what we have learned, especially from infrared and radio surveys, is that it is not a handful. It is not dozens. It is not even hundreds. Evidence points to thousands of galaxies shining through the cosmic fog, some faint, some massive, some part of larger structures that reshape our understanding of what lies nearby in the universe. The darkness was never empty. It was simply unreadable in the language we first used. Here is an image that makes it easy to feel. Imagine you are standing in your kitchen at night, and the window is black. Outside, the world is still there, trees, roads, distant houses. But your indoor lights reflect off the glass, and suddenly your own room becomes the only thing you can see. That is what the Milky Way does to astronomers. The bright foreground stars are the room lights. The dust is the glass. The universe beyond is the night landscape you cannot reach with your eyes, unless you change the lighting, unless you change the wavelength, unless you learn to look differently. A second example is even simpler. Think of driving toward the horizon at sunset, when the sun sits low and turns the windshield into a sheet of fire. You know the road continues. You know other cars are there, but your vision becomes unreliable, and you slow down, not because the road ends, but because certainty ends. For decades, astronomers slowed down at the galactic plane for the same reason. They did not want to crash into false conclusions. But then came the instruments that could see what the eye could not. Infrared light, longer in wavelength, can slip through dust more easily than visible light. Radio observations can detect hydrogen gas, the vast, quiet reservoirs that galaxies carry like invisible oceans. With these tools, the zone of avoidance began to change its character. It stopped being a blank. It became a crowded hallway, full of doors we had never tried to open. And when those doors began to open, the question shifted from what is hidden to what we have missed. Because missing galaxies is not just missing pretty pictures. Galaxies have mass. Mass means gravity. Gravity means motion. And the universe keeps a strict accounting of motion. If you leave out a large chunk of mass from your map, the universe will not politely ignore your mistake. It will show up as a pull you cannot explain, as a drift in galaxy velocities, as a cosmic something tugging at everything nearby. This is where the consequences become profound. By not seeing through the Milky Way's veil, we risk misunderstanding the large-scale structures near us. We risk underestimating or misplacing the sources of gravitational attraction that shape how galaxy groups move. We risk telling a story of cosmic architecture with missing pillars and then wondering why the building does not stand straight. Even our sense of what is local in the universe can be distorted, because the hidden region sits in directions that matter for mapping flows of galaxies and tracing the scaffolding of the cosmos. There is a quiet humility here that feels almost spiritual, though it is entirely scientific. We are not outside the Milky Way looking in. We are inside it. We are like ants trying to map a cathedral while standing in its shadow, while dust drifts through the air, while stained glass throws colored light across the floor. And yet, we persist, because curiosity is one of the few forces in nature that does not fade with distance. Carl Sagan once said, "We are a way for the cosmos to know itself." The zone of avoidance is a reminder that knowing is not a single act. It is a long apprenticeship. It is returning to the same mystery again and again, each time with better tools, better questions, and a deeper patience. So yes, astronomers ignored this region for decades, but the better word is that they respected its power to deceive. And now, with new eyes, they are walking back toward it, not with certainty, but with curiosity sharpened into method. Because the most meaningful discoveries are not always hiding in the farthest distances. Sometimes they are hiding in the nearest shadows. And that brings us naturally to the next step. Before we talk about what might be inside this blind spot, we have to sit with the simplest truth first, the truth that begins the whole story. There is a blind spot we have been living with all along, and it was never empty. What if the biggest mystery in our own galaxy is not a distant black hole, not a faraway supernova, but a simple fact we keep forgetting? That there is a direction in the sky where our eyes, and even our most familiar telescopes, are almost blind. We tend to trust sight as if it were truth itself. We look up and feel we are seeing space, as though the universe is a clean window and the stars are nailed to its glass. But the Milky Way is not a window. It is a living, breathing storm of light and dust, and in some directions that storm thickens into a veil. Not an empty veil, but a crowded one. A place where the galaxy holds its secrets close, like a book pressed shut by time. The difference begins with something humble. Wavelength. Visible light, the kind your eyes evolved to notice, is small and delicate. It is easily scattered, easily absorbed, easily bruised by dust grains floating between the stars. Those grains are tiny, but not tiny compared to visible light. So when visible light tries to pass through a dense cloud of dust, it doesn't glide through like a swimmer in open water. It collides. It ricochets. It gets swallowed and re-radiated in quieter forms. And the result, from our perspective, is a darkness that feels like absence. Yet it is not absence at all. Infrared is what happens when you loosen your grip on the visible and let the universe speak in warmth. Infrared light has longer wavelengths than visible light, which means it can slip past dust more easily. Not perfectly, not always, but far better than the light your eyes rely on. If visible light is a whisper that dust can interrupt, infrared is a lower note that travels through the same room with less resistance. And radio waves go even farther, stretching into wavelengths so long that dust becomes almost irrelevant, like sand grains trying to stop a rolling ocean swell. This is why infrared and radio astronomy feel like a kind of awakening. Not because they invent new realities, but because they reveal the reality that was already there, patiently waiting behind the veil. Carl Sagan once said, "Somewhere, something incredible is waiting to be known." The beauty of that line is that it doesn't demand drama. It doesn't promise monsters. It simply reminds us that ignorance is often geographical. Sometimes the unknown is not far away. Sometimes it is simply behind something. Imagine you are standing on a mountain road at night and fog pours through the trees. With your headlights on, the fog becomes brighter, not clearer. The beams strike the droplets and scatter back into your eyes, turning the world into a glowing wall. But if you change the way you look, if you use a different kind of light, the wall thins. Infrared is like switching from headlights that bounce off fog to a quieter beam that can reach deeper down the road. It doesn't remove the fog. It changes your relationship to it. Or think of a hospital scene, calm and clinical, where a person's body is not treated as a mystery but as a map. An X-ray does not show you skin and color and surface detail. It shows you what matters for that question: the bones, the structures, the hidden architecture. In the same way, radio astronomy is not trying to paint pretty pictures of the galaxy. It is trying to measure what the galaxy is made of: the hydrogen that fills the spiral arms, the molecular clouds where stars are born, the invisible currents of gas moving like weather across tens of thousands of light years. Different eyes for different truths. And when we finally look through dust with these other eyes, what appears is not emptiness. What appears is abundance. Dense star fields, star-forming regions, knots of gas so thick they are like cosmic wombs. The bright, complicated heart of the Milky Way, crowded with old stars, newborn stars, and the restless material that will become future suns. Even beyond our galaxy, in the direction where visible light struggled most, astronomers begin to find external galaxies, clusters, structures that were always there but were simply muffled behind our own galactic foreground. This is where the question becomes almost philosophical. If a region looks empty to one kind of observer but overflows with detail to another, was it ever empty? Or were we just listening on the wrong frequency? There's a quote from Neil deGrasse Tyson that lands gently but firmly in moments like this: "The universe is under no obligation to make sense to you." In practice, that doesn't mean the universe is irrational. It means our default senses are not the standard by which reality must present itself. The cosmos does not tailor its secrets to human eyes. It offers clues in many languages, and we spend centuries learning how to translate them. So what is the real difference between infrared and radio telescopes compared to ordinary vision? Ordinary vision is like reading a single chapter of a vast book and assuming you understand the plot. Infrared is another chapter, one written in heat and hidden starlight. Radio is the deep background narration, the slow vibrations of hydrogen, the faint signals of molecules, the structure of the galaxy traced not by sparkle but by substance. Visible light loves the dramatic stars, nebulae glowing, the sharp edge of a bright galaxy. Radio loves the patient, the gas between the stars, the invisible scaffolding that decides where stars can form and where they cannot. Infrared sits between, revealing stars behind dust, and dust itself as it warms and shines faintly in its own way. And when you look through the dust, something else happens inside the mind. The sky becomes less like a dome and more like a landscape with layers. You realize the Milky Way is not a flat band of light. It is depth. It is distance. It is overlapping rooms in a mansion so large that light takes tens of thousands of years to cross it. Some rooms are bright and open. Some rooms are sealed with curtains of dust. But sealed does not mean vacant. This matters because the idea of a blank patch on the map has always tempted people to fill it with fantasies. Science doesn't need fantasies to stay compelling. The truth is already poetic. The truth is that our galaxy contains regions so dense, so complex, so alive with material, that visible light cannot reliably carry their stories to us. We are not being teased by emptiness. We are being humbled by richness. And perhaps the most beautiful part is that these methods do not just reveal more objects. They reveal more patience. They remind us that discovery is often a shift in perception rather than a conquest of distance. A hidden place does not require drama to be meaningful. A cloud of dust can be as important as a star. A silent radio line from hydrogen can be as revealing as the brightest nebula. A region once labeled a void can become a doorway. So is the empty region truly empty? No, not in the way people mean when they say empty. It may be empty of visible detail in certain images, but it is full of matter, full of structure, full of story, full of the very ingredients that make galaxies evolve, full of the raw material that becomes suns and planets, and perhaps, in the long arithmetic of cosmic time, living things that will also look up and wonder what lies behind their own veils. And that is the quiet promise of this topic. Not that we will find a single shocking object hiding in the dark, but that we will learn to see the Milky Way as it truly is, not as our eyes prefer it to be. Because once you accept that the galaxy has a blind spot, you start to notice a deeper truth. Every method of seeing creates its own kind of darkness. Every answer creates a new edge of the unknown. In the next stretch of our journey, we begin exactly where the mystery is most personal. Not out there in distant galaxies, but right here, in the blind spot we are living with. Have you ever wondered why so many galaxies seem to drift in the same direction, as if the universe itself is leaning? When astronomers map the motions of galaxies near us, they do not only see expansion, they also see a subtle, collective slide. It is like watching leaves on a wide river. Most of the water moves downstream because the river is flowing. Yet some leaves suddenly angle toward a hidden channel, pulled by a current you cannot see from the surface. That is the feeling of this mystery. At first, it sounds impossible. Space is enormous, and galaxies are separated by distances so vast that our minds soften and blur at the edges when we try to imagine them. So why would many galaxies, across a huge region, appear to be drawn toward one general patch of sky? Why would their motion share a direction, like iron filings responding to an unseen magnet? And if they are being pulled, what could be massive enough to do the pulling? To understand this, we have to hold two truths in the same breath. The universe is expanding, and that expansion carries galaxies away from each other on average. Yet galaxies also have their own local motions, the way a boat can drift with the tide while still steering toward a lighthouse. Astronomers call these extra motions peculiar velocities, but there is nothing peculiar about them. They are simply gravity at work, shaping the dance beneath the grander music of expansion. A galaxy does not only move because space stretches. It also moves because mass nearby bends the geometry it lives within, and the galaxy responds. This is where the first big question becomes more than a curiosity. If many galaxies seem to be drawn toward the same direction, it suggests there is an excess of mass there. Not necessarily one single object, not necessarily a monster you can point to like a planet or a star. It could be a wide landscape of mass, spread across clusters and superclusters, a continental shelf of matter in the cosmic ocean. And sometimes, the reason we struggle to identify it is not because it is unreal. It is because our view is blocked by our own home. We live inside the Milky Way, and the Milky Way is not transparent. Dust and gas lie thick along its disk, and in certain directions they form a curtain so dense that visible light cannot easily pass through. So the sky can look strangely quiet in that direction, not because nothing is there, but because the stage lights have been dimmed by a veil. Now, the second question arrives, heavy and honest. What is massive enough to tug on galaxies across such distances? Gravity weakens with distance, and on cosmic scales, you need truly staggering mass to create a measurable pull. Not a star, not a single galaxy, but great gatherings of galaxies, clusters woven into clusters, the way mountain ranges gather into continents. When we speak of an attractor in the universe, it is rarely a solitary thing. It is more like a region where matter is piled higher than average, where gravity's whisper becomes a chorus. And even that chorus does not shout. It nudges. It persuades. It leans on the motions of galaxies so gently that only careful measurement reveals the pattern. There is a beautiful humility in how we detect it. We do not see the pull directly the way we see a bright star. We infer it from the way galaxies move, from redshifts, from subtle deviations from what pure expansion would predict. It is the universe teaching us a quiet lesson. Sometimes the deepest forces do not announce themselves with light. Sometimes they speak through motion. Sometimes they leave fingerprints not on the eye, but on the trajectory. John Wheeler captured this relationship with a line that has become almost a mantra in modern physics. Space-time tells matter how to move. Matter tells space-time how to curve. In one sentence, the mystery becomes less like a ghost story and more like a readable language. Matter gathers, space-time curves, galaxies respond, and their collective drift becomes a sentence written across millions of light years. If we learn to read that sentence, gravity becomes a kind of lantern. Not a lantern that shines outward with photons, but one that illuminates by revealing shape, by revealing slope, by revealing the invisible architecture beneath the visible sky. Einstein, too, gave us a way to feel the strangeness without turning it into spectacle. Gravity is not a force, but a consequence of the curvature of space-time. When you hold that idea gently, the question changes texture. You stop imagining gravity as a rope tugging galaxies across darkness. You begin imagining gravity as the contour of a landscape and galaxies as travelers following the easiest paths downhill. The direction of the drift is not a command. It is a slope. Here is an image that makes this easier to picture, and it is our first simple example. Imagine a broad, stretched fabric, like a trampoline, flat and calm in a quiet room. Now place a heavy bowling ball in the center. The fabric dips, not because the fabric wants to trap the ball, but because weight changes the shape of what supports it. If you roll a marble nearby, the marble curves inward, not because a hand pulls it, but because the surface itself has been reshaped. On cosmic scales, the trampoline is space-time, and the bowling ball is not one object but a vast concentration of mass, clusters piled upon clusters. Galaxies are the marbles. They follow the curvature. They arc. They drift. And from far enough away, their shared direction is the signature of the dip. But then comes the haunting part, the part that makes the third question feel almost philosophical. What if the dip is hidden behind the Milky Way's dust, behind the bright clutter of our own stellar neighborhood? What if light cannot easily show it to us? Do we give up? Or do we listen to gravity instead? This brings us to a second example, softer, more human, and perhaps more intuitive. Think of walking through a dark room you know well, a room with furniture placed in familiar positions. If the lights are out, your eyes give you almost nothing, yet you can still navigate. You feel the air change near a wall. You sense the space open up near a doorway. You move with the memory of shape. In the same way, gravity lets us navigate a universe where light is blocked. Even if dust hides the source, the motions of galaxies can outline the furniture of the cosmos. They can suggest where the walls of mass are. They can reveal where the doorway into a denser region might be. And that is why the question, can gravity reveal what light cannot, is not only scientific, it is almost poetic. Because the answer is yes, again and again, across modern astronomy. We weigh galaxies we cannot fully see by how they spin. We infer invisible matter by how it bends the light of more distant objects. We trace the presence of mass by the way it shepherds galaxies into clusters and filaments. Light is a storyteller, but gravity is an editor. It shows us what the story must contain, even when pages are missing. Still, we should be careful with our wonder. When we say galaxies are being pulled toward one region, it does not mean there is a single cosmic predator waiting there. It means the distribution of matter is uneven, and that unevenness creates flows. It means our local neighborhood, our galaxy group, and even larger structures participate in a slow migration within the cosmic web. It means the universe is not a uniform fog. It is a textured tapestry, with knots and threads, with dense nodes and spacious voids. and where the tapestry knots, gravity deepens. In the end, the most valuable thing this mystery gives us is not a monster to fear, but a method to understand. We learn that motion is information. We learn that absence of light is not absence of reality. We learn that the universe can be studied not only by what shines, but by what shapes. And perhaps we learn something quieter about ourselves. That we are creatures who keep walking even when the room goes dark, trusting that shape is still there, trusting that the unseen still leaves traces. So if you find yourself staring at that hidden direction in the sky, the one masked by our own galaxy's dust, hold on to this thought. The blind spot is not a void of meaning. It is a reminder that knowledge often begins where vision fails. And in the next stretch of our journey, we will step directly into that blind spot we are living with, and ask what the Milky Way's veil might be hiding, and how we can learn to see without seeing. What if a huge part of our cosmic neighborhood is moving, not randomly, but as if answering a silent call from behind a curtain we cannot see? That question is where the Great Attractor enters the story, not as a monster, not as a headline, but as a measured unease in the data, a whisper in the motions of galaxies that should not be whispering in unison. When astronomers map the universe, they do more than take pictures. They measure speeds. They compare where a galaxy appears to be going versus where it should be going if the universe were expanding smoothly. And again, in our local region of space, the numbers lean the same way. Like tall grass bending to a wind you cannot feel on your skin. Like a slow tide pulling at countless islands, all at once, all together. This is why the Great Attractor is so compelling. It is not something we first saw. It is something we first felt, through gravity, through motion, through the stubborn honesty of measurement. To ask what the Great Attractor truly is, we have to begin with what it is not. It is probably not a single, clean, solitary object, like one giant black hole sitting alone in the dark. The evidence points instead to a crowded region, a gravitational landscape made from many structures layered together, where clusters of galaxies and dense filaments add their weight to a single overall pull. In other words, the Great Attractor is less like a single thing and more like a destination shaped by many roads. A basin in the cosmic terrain where matter has gathered over billions of years. A place where the universe is slightly heavier than it looks from our vantage point. If you want a simple image, imagine you are on a ship at night, far from shore. The sea looks flat, the horizon looks calm, and yet the vessel begins to drift. You check the wind, it is minimal. You check the engine, it is steady. But the ship continues to slide, because beneath the surface there is a current, massive and unseen. And it does not care whether you understand it or not. The Great Attractor is that current, written across millions of light years. Not a mystical force, not a cosmic intention, but gravity doing what gravity always does. Gathering, guiding, pulling softly, relentlessly, with a patience older than memory. So is it one object or a whole cluster of galaxies? The most responsible answer is that it is a region dominated by multiple concentrations of mass, including galaxy clusters, superclusters, and the thick connective tissue of the cosmic web. Think of it as a convergence, where several heavy neighborhoods overlap their influence, and our own neighborhood responds. This is also why the Great Attractor has evolved in meaning over time. At first it sounded like a single culprit, a single source of the pull. But as maps improved, as surveys widened, scientists began to see that the story is richer. The pull we measure may come from a combination of structures, some nearer, some farther, each adding a note to the same gravitational chord. There is a quiet beauty in that, because the universe rarely offers us simple villains. It offers us systems. It offers us layers. It offers us truth by accumulation, not by revelation. And this is where the second question becomes almost philosophical. If it is not one object, then what are we really detecting? We are detecting the shape of mass itself, the way matter has arranged its greatness in the dark, and the way that arrangement leaves fingerprints on motion. Somewhere, something incredible is waiting to be known, Carl Sagan once said. And the Great Attractor feels like one of those places where that sentence becomes almost literal. Because the most incredible part is not that something is pulling on us. The incredible part is that we can infer the pull at all, using nothing but light, distance, and the mathematics of movement. Now comes the question that makes this story feel like a cosmic fable. Why is it hidden behind the dust of the Milky Way? Why does it sit in a direction where our own galaxy, our own home, blocks the view? The answer is both simple and humbling. We live inside a spiral galaxy filled with dust and gas, especially along its flat disk. When we look out across that disk, we are peering through a thick, smoky lane of interstellar material that absorbs and scatters visible light. It is as if the Milky Way has its own weather, its own fog banks, drifting between us and the wider universe. Here is another image to make it real. Imagine standing in a bright city at dawn, trying to see a mountain range on the horizon. The mountain is there, immense and unmoving. But between you and it lies haze, smoke, humidity, and the glare of your own streetlights. If you only use your naked eyes, you might swear there is nothing out there at all. Yet the mountain remains, and the only change required is not the mountain moving closer, but you learning to see differently. That is exactly what astronomers have done. When visible light fails, they turn to wavelengths that travel through dust more easily, like infrared and radio. They use the universe's own variety of light as a set of keys, each one opening a different lock. And step by step, the so-called hidden sky becomes less hidden. The zone of avoidance, once a polite admission of ignorance, becomes a frontier of patient discovery. Not because the universe becomes more cooperative, but because our instruments become more wise. Still, the Milky Way's dust does more than block the view. It complicates it. It creates gaps in our surveys. It forces us to stitch the map together with indirect methods, like measuring how galaxies move, how the cosmic microwave background frames our motion, how local flows reveal distant mass. This is why the Great Attractor is a masterclass in scientific humility. It reminds us that seeing is not the only path to knowing. It reminds us that gravity is a kind of language, and motion is its grammar. It reminds us that the universe can be understood even when it refuses to be photographed cleanly. Stephen Hawking once wrote, "Remember to look up at the stars and not down at your feet." In the context of the Great Attractor, that advice becomes even more poignant, because when we look up, we also have to accept what blocks our view. We have to accept that our home galaxy is both our cradle and our blindfold. And yet, there is something strangely meditative in that limitation, because it mirrors the human condition. We also live inside our own galaxy of assumptions, habits, and inherited stories. We also have zones we avoid, not because they are empty, but because they are difficult to see through. So the Great Attractor becomes more than a feature on a map. It becomes a reminder that the cosmos is not presented to us like a neat diagram. It is encountered. It is approached. It is slowly revealed as our questions become better and our patience grows deeper. If you listen closely, the real lesson is not that something enormous is out there. The lesson is that the universe leaves evidence everywhere, even in the places we once considered inaccessible. Even in the directions where our own dust clouds say, "Not yet." And perhaps that is the most quietly thrilling part of this story. We are not staring at a blank wall. We are staring at a curtain that can be read, not only with eyes, but with inference, with physics, with the soft persistence of curiosity. Because the Great Attractor, whatever its full shape turns out to be, is already teaching us something profound. That in a universe this vast, knowledge is often born the same way galaxies are born. Slowly, through accumulation, through gravity's gentle insistence that hidden things still have weight. And if that is true, then the question that remains is almost unavoidable. If one of the most influential regions in our local cosmos spent so long hidden behind our own galactic dust, what else might be shaping our story from behind veils we have not yet learned to see through? What if the darkest patch of our galaxy is not empty at all, but heavy, quietly bending the paths of stars and galaxies like an unseen hand? That question sits at the edge of our comfort, because it forces us to admit something simple and unsettling. We do not only live in the Milky Way, we live inside its limitations. There are directions where our instruments struggle, where dust becomes a curtain, and where gravity keeps whispering that something is there, even when light refuses to testify. When astronomers speak about a hidden mass, the first instinct is to assume it is normal, just ordinary matter in an inconvenient place. Cold clouds of hydrogen, dense knots of dust, faint galaxies stacked behind the galactic plane. The universe is full of perfectly reasonable things that look mysterious until you change the wavelength. And yet, gravity has a way of making ordinary explanations feel too small. Because gravity does not care about our stories. It only cares about mass. This is where the scientific mind becomes both humble and brave. Humble, because we know how easily we can fool ourselves. Brave, because we still follow the evidence into regions that feel like myth. As Carl Sagan once reminded us, extraordinary claims require extraordinary evidence. It is a simple sentence, but it is also a lantern. It keeps our curiosity lit without letting it burn down the house of reason. So we ask the first question with care. Is the hidden mass completely normal? Or is it something that does not fit comfortably inside our catalogue of familiar cosmic furniture? In many cases, normal can be more than enough. A thick wall of interstellar dust can erase entire star fields from visible view, the way fog can swallow a mountain at dawn. And behind that fog, there may be ordinary galaxies. Not strange at all, simply distant and dim, waiting for infrared eyes to notice them. But sometimes the motions we observe hint that the story is not just about what we cannot see, it is about what we can measure indirectly. Imagine you are standing in a calm room, and a heavy curtain covers one side of the wall. You cannot see what is behind it, but you notice the curtain is slightly pulled inward, as if something on the other side is drawing it. You do not need to see the object to suspect its weight. This is how gravity works in astronomy. We watch how stars orbit, how gas clouds drift, how entire galaxies lean in their trajectories. And from those motions, we infer the presence of mass, like feeling the pull of a hidden magnet through a table. Now imagine another example. You are on a lake at night, and the surface is dark. You cannot see what moves beneath, but you notice a broad, slow swirl of ripples, a pattern too large to be caused by wind alone. Something massive has turned under the water, and the surface has confessed it. In the cosmos, light is that surface, and motion is the ripple. We study the ripple because the deep thing does not show itself willingly. This is where the second question opens like a doorway. Could there exist structures we have never truly met before? Not aliens in the cinematic sense, not fantasies dressed as science, but genuine cosmic architectures that our models have not fully anticipated. Vast filaments of galaxies hidden behind dust lanes. Dense superclusters partly masked by the Milky Way's own bright confusion. Strange distributions of dark matter shaping the flow of visible matter like an invisible riverbed. Even within mainstream cosmology, the universe is not a smooth soup. It is a web, and the web has knots and voids, thickened places where matter gathered for billions of years. Some of those knots may sit precisely where our galaxy blocks our gaze. In moments like this, I often recall the quiet discipline behind discovery. The late Stephen Hawking put it plainly, "The greatest enemy of knowledge is not ignorance, it is the illusion of knowledge. That illusion is seductive. It tells us the map is complete because it looks complete. But a map can feel finished while still missing an entire continent hidden by clouds. The Milky Way, bright and beautiful, is also one of those clouds. It gives us stars to wonder at, and it takes away the view beyond them. So where is the boundary between science and speculation? It is not a wall. It is more like a shoreline that moves with the tide. Science begins with a measurable clue: a drift in velocity, a shift in a spectrum, a distortion in a gravitational lens, a statistical pattern that refuses to be coincidence. Speculation begins when we leap too far from that clue, when we start loving the story more than the data. But there is also a third space, a necessary space, where we form hypotheses, not as beliefs, but as testable dreams. A hypothesis is a bridge made of questions. It reaches toward the unknown, but it anchors itself to the ground we can stand on. This is why the mystery of the galactic blind spot matters. It teaches us how to think without preaching. It shows that the universe can be both knowable and hidden. That evidence can arrive without images. That patience can be a scientific instrument. We do not need to manufacture wonder. Wonder is already there, in the simple fact that gravity can point to what light cannot reveal. And perhaps this is the most meditative truth of all. We are not separate from the cosmos we study. Our ignorance is part of its landscape. Our curiosity is part of its motion. We look into the darkness and feel a pull, not only of mass, but of meaning, because every blind spot is also an invitation to change the way we see, to admit what we do not know, to let questions be honest, and let evidence be sacred. So when we ask whether the hidden mass is normal, whether unknown structures could exist, whether we can draw the line between science and speculation, we are really asking one deeper thing: how do we stay faithful to reality while still daring to explore the parts of reality that refuse to show their face? What if the greatest limitation in our understanding of the universe is not our technology, but our address? We live inside the Milky Way, and that simple fact shapes everything we think we know. It is like trying to draw the shape of a cathedral while standing in the nave, surrounded by pillars and incense and echo, unable to step outside to see the full silhouette against the sky. From here, the galaxy is not a neat spiral on a textbook page. From here, it is a river of stars and dust that cuts the night in half, bright in places, bruised in others, and always shifting as Earth turns like a slow compass. When we point our instruments outward, we do not begin from a neutral vantage point. We begin from inside a luminous storm of gas, magnetic fields, cosmic rays, and drifting clouds of dust so fine it can hide entire populations of stars behind a thin veil. That veil does not just block light. It edits our story. It decides which galaxies get to enter our catalogues, which directions seem empty, which patterns appear real, and which truths remain muffled, like music heard through a wall. In that sense, blind spots are not only patches of darkness on a sky map, they are gaps in the mind, created whenever reality outgrows the way we are able to look at it. Carl Sagan once offered a gentle warning that still feels like a compass for this conversation. Somewhere, something incredible is waiting to be known. But there is a second part to that thought that we often forget. To know something incredible, we must first admit how much of the sky we have not truly met. A simple example makes this painfully clear. Imagine you are driving at night in heavy fog. Your headlights give you a bright tunnel of visibility, and beyond that tunnel, the world does not disappear. It simply becomes inaccessible. You might be tempted to describe the landscape as empty, because you cannot see the trees, the hills, the houses, the animals standing just beyond your beam. In the same way, living inside the Milky Way gives us a headlight view of the cosmos. We see well where the dust is thin, and we struggle where the dust thickens into a dark lane across the heavens. Astronomers even have a name for the most famous of these obstructions: the zone of avoidance, a region where the galaxy's own material makes distant structures difficult to detect in visible light. It is not that the universe is missing there. It is that our window is dirty in that direction. And once you understand this, a deeper question arrives quietly, almost like a meditation. If our maps have blank spaces because our galaxy blocks our view, How many other blind spots exist that we have not yet realized are blind spots at all? Not darkness on the sky, but darkness in our assumptions. Because the most dangerous blind spot is the one that looks like certainty. Another example, softer but even more revealing, comes from sound rather than sight. If you have ever tried to identify a song while standing outside a concert hall, you know the strange frustration of it. You hear bass notes pulsing through the walls. You sense rhythm. You feel the crowd's roar, but the melody is incomplete. You might guess the song and be wrong, not because you are careless, but because you are missing frequencies. Now translate that into astronomy. Visible light is only one frequency band of reality. The Milky Way absorbs and scatters much of it. But when we learn to listen in infrared, in radio, in X-rays, in gamma rays, the same region can transform from silent darkness into a busy marketplace of signals. Hidden star nurseries appear. Dense clouds glow with heat. Structures emerge where a visible light map looked like a hole torn in the universe. So the question becomes less about whether the cosmos has secrets, and more about whether we are using the right senses to approach them. This is where education becomes a kind of humility, because science is not only a collection of answers, it is the disciplined art of noticing what our previous answers could not include. Stephen Hawking captured the spirit of that discipline with a line that feels almost like a vow: remember to look up at the stars and not down at your feet. To look up, in this case, means more than lifting your eyes. It means lifting your methods. It means refusing to treat the current map as the final territory. So is our map of the universe complete. It is extraordinarily beautiful, and it is still incomplete. We have charted billions of galaxies, traced the web-like structure of cosmic filaments, measured the afterglow of the early universe, and learned that most of what exists is not directly visible to our eyes at all. We speak of dark matter and dark energy not as poetic metaphors, but as placeholders for real effects we can measure and cannot yet fully explain. Even the notion of an observable universe is a reminder that the cosmos is larger than our access to it, bounded not by a wall, but by time and the speed of light. And within our own neighborhood, inside our own spiral home, there are still corridors of obscuration where discovery waits behind dust like a patient figure behind a curtain. The deepest impact of living inside the Milky Way, then, is not merely that it blocks our view. It teaches us how easily perspective becomes doctrine. It reminds us that every civilization, every era, every generation stands inside some kind of galactic weather, some kind of conceptual fog, convinced that the edge of visibility is the edge of reality. But the universe has a quiet way of correcting us. It does not argue. It simply reveals more when we learn how to ask. And that is the promise that carries us forward from here. If the Milky Way has blind spots, then the next step is not to fear the darkness, but to study the veil itself. Because sometimes the most important discovery is not what is hidden behind the curtain, but the realization that a curtain was there all along. So let me leave you with a question to carry into what comes next. If our own galaxy can hide parts of the universe from us, what else might the universe be hiding in the places we have not yet learned to see? What if the biggest mystery in our galaxy is not a distant planet or a secret star, but a place we have been staring at our whole lives without truly seeing? There is a broad band of sky where the Milky Way becomes a curtain, not a window. A dense river of dust and gas crosses our view and turns entire directions into a kind of astronomical silence. It is not that nothing is there. It is that light, at the wavelengths our eyes love most, struggles to escape. So when we ask how much of this blind spot we have explored, the honest answer is both comforting and unsettling. We have peeled back a great deal, but not all at once, and not with one instrument. Infrared surveys can slip between the grains of dust that block visible light, and radio telescopes can listen to hydrogen clouds that whisper where stars cannot shout. With these tools, astronomers have mapped many hidden structures and uncovered galaxies that were once completely erased from our charts. And yet the deepest, Most crowded lanes near the galactic plane remain complicated because the fog is not a thin veil. It is a living, layered storm of matter, glowing, absorbing, scattering, and confusing the story with too many overlapping voices. That is why the blind spot is not a single black patch you can simply look through. It is more like trying to understand a city by listening from inside a crowded subway station. You hear footsteps, echoes, announcements, 1,000 conversations at once. You can learn a lot, but you must separate signals, filter noise, and accept that some details will stay ambiguous until you change your method. This is where the remaining mysteries begin to feel almost personal. Some uncertainties are about what lies behind the dust, ordinary in a cosmic sense, like more galaxies, more star-forming regions, more clusters. Other uncertainties are about how mass is distributed on larger scales, because gravity does not care whether we can see the source. We notice motions, subtle drifts, and patterns in the way galaxies flow through space, and we wonder if the hidden structures behind our own galactic curtain are part of something even larger, an arrangement of matter that shapes our local cosmic neighborhood. Somewhere, something incredible is waiting to be known. Carl Sagan's words land softly here, because the blind spot teaches a quiet humility. It reminds us that the universe does not yield its secrets to a single sense. It asks for patience, for multiple ways of knowing, for the willingness to admit that our first picture was incomplete. To make that idea tangible, imagine standing in a thick morning fog on a mountain road. With your eyes alone, the world ends a few steps ahead, and the trees become ghosts. But switch on a different kind of vision, like a thermal camera, and suddenly warm bodies, hidden paths, and the outline of the landscape appear. The fog did not change. You changed the way you asked the question. Our galaxy's blind spot works in a similar way, except the fog is made of interstellar dust, and the camera is an observatory tuned to infrared or radio light. A second example is even simpler, and perhaps more haunting. Think of trying to understand an orchestra while wearing earplugs that block most notes. You still sense rhythm. You still feel vibrations. You might even guess the melody. But only when you remove the earplugs, or trade them for a device that amplifies the missing frequencies, do you hear the full structure, the harmonies, the hidden instruments that were always playing. In astronomy, changing wavelengths is like removing those earplugs. The universe has been performing the whole time. We are the ones learning how to listen. And that brings us to the future, where the question is not merely whether we will see the blind spot completely, but whether completely is even the right word. In practice, science advances by layering perspectives, not by achieving a final, perfect view. More sensitive infrared surveys will continue to map star formation and galaxies through dust. More powerful radio arrays will trace hydrogen with finer detail and reveal structures buried in confusion. Better algorithms will separate overlapping signals, like turning a noisy crowd into distinct, readable voices. And when new telescopes work together across wavelengths, the blind spot shrinks, not as an act of conquest, but as an act of refinement. All truths are easy to understand once they are discovered. The point is to discover them. Galileo's line fits here because discovery is often less about brilliance than about persistence. The blind spot is a lesson in method. When one approach fails, we do not surrender. We pivot. We widen the spectrum, literally and metaphorically. Still, it is wise to keep one gentle mystery in our pocket. Even if future technology reveals nearly everything hidden behind the Milky Way's dusty lanes, the universe will not run out of shadows. Every answered question sharpens a new one. Every map reveals the edge of what we have not mapped. And perhaps that is the deeper value of this blind spot, not fear, not sensational surprise, but a kind of cosmic meditation, a reminder that knowledge grows like dawn, not like a light switch. So we continue, step by step, frequency by frequency, learning how to see what has always been there. And as we move forward, the most important question may not be what is hiding in the darkness. It may be what the darkness reveals about us, our tools, our patience, our hunger to understand. Now, let us lean closer to that curtain of dust itself, because before we can fully appreciate what might be behind it, we have to understand the veil we are trying to lift. What if the darkest region of our Milky Way is not a void at all, but a mirror held up to the limits of the human mind? What if the blind spot is less about what the universe refuses to show us, and more about what our senses were never built to see? When we speak about a blind spot in the galaxy, we are really speaking about a boundary in perception, a place where ordinary starlight is softened, scattered, and swallowed by dust, until the sky itself seems to fall silent. And in that silence, a quiet lesson begins to form. Not that knowledge is impossible, but that knowledge is always conditional. It depends on where you stand, what tools you carry, and whether you have the patience to look again. Carl Sagan once reminded us that somewhere, something incredible is waiting to be known. The blind spot feels like the living proof of that sentence, because for centuries, that dark lane across the sky looked like absence. Yet the moment we learned to listen with radio waves and see with infrared, the emptiness changed character. It was never empty. It was simply speaking in a language we had not learned yet. Stephen Hawking offered another kind of compass when he said, "Remember to look up at the stars and not down at your feet." In the context of the blind spot, that advice becomes more than inspiration. It becomes method. Looking up is not only a gesture of wonder, it is a discipline of humility. Because the universe does not reveal itself in one spectrum, and reality does not arrange itself for human convenience. The cosmos is vast, yes, but our first obstacle is often smaller and closer, a thin veil of dust, a limitation of the eye, a habit of assuming that what we cannot see must not matter. Imagine standing in a desert at night, and a mountain blocks half the horizon. You might believe there is nothing beyond it, not because nothing exists, but because your view ends where the stone begins. The galactic blind spot is like that mountain, except the mountain is made of drifting dust, grains, and cold clouds, so delicate they seem harmless, yet powerful enough to hide entire cities of stars. Or picture trying to understand a symphony while wearing heavy earmuffs. You may still feel the vibrations, you may still sense the rhythm, but the melody remains incomplete until the muffling is removed. In the same way, gravity and motion can hint that something massive is playing behind the veil. Even before light delivers the full song, we notice the pull, we notice the pattern, and slowly we admit a truth that can feel unsettling at first. Our ignorance is not always a lack of effort. Sometimes it is simply the wrong wavelength. That is why the blind spot does not only raise an astronomical puzzle, it raises a human one. How many discoveries are waiting, not in distant galaxies, but in the places we have trained ourselves to ignore? How many empty spaces in our maps are really unopened doors? And if the universe still hides, is it refusing us, or inviting us to mature, to become the kind of observers who do not confuse darkness with nothingness? So let the blind spot be what it truly is, a soft but relentless teacher, a reminder that our instruments evolve, our models improve, our certainty should remain gentle, and our curiosity must stay awake. Because perhaps the universe is not withholding its secrets out of cruelty, but offering them the way mountains offer paths, only to those willing to climb. In the end, the story of the galactic blind spot is not really about what hides behind dust and darkness. It is about how easily the human mind mistakes silence for absence. For a long time, we believed that what we could not see simply was not there. Yet the universe kept moving, pulling, shaping itself in ways that quietly contradicted our assumptions. The blind spot teaches us that reality does not disappear just because our eyes fail. It waits. It speaks in other frequencies, through gravity, through motion, through subtle patterns that only reveal themselves when we learn to listen differently. What once appeared as an empty scar across the sky slowly becomes a crowded, dynamic region when our tools and perspectives evolve. Not because the universe changed, but because we did. There is something humbling in realizing that some of the greatest structures influencing our cosmic neighborhood were hidden not by distance, but by familiarity. They were concealed by the very galaxy we call home. We were standing inside the obstacle all along. And perhaps that is the quiet message woven into this story. Being inside a system limits what we can see of it, whether that system is a galaxy, a civilization, or our own beliefs. The blind spot reminds us that knowledge is not a finished map, but a living process. Every generation redraws the borders of the known world, only to discover new edges. What feels complete today may look unfinished tomorrow. What feels obvious now may once have been invisible, and so the darkness in the Milky Way becomes something gentle rather than threatening. Not a wall, but a threshold. Not a refusal, but a pause. It invites patience instead of certainty, curiosity instead of conclusion. If the universe still hides parts of itself, it may be because understanding is not meant to arrive all at once. It unfolds as we learn how to look, again and again, with better eyes and quieter minds.